Hello, class. Welcome to week 10 of our anthropology course. All right, so to start this lecture, and I'll do a quick little recap. 2 weeks ago, we started talking about the hominins. And what I was discussing then was that there were many different species of hominins living in Africa, starting at around 6 million years ago. That's when this group of apes first became bipedal. And they were a very diverse group for a while. For the next few million years, there were many species walking around Africa. And during that time, there were multiple types of climate change, right? First, there was the big drying period that shrunk the rainforest and started hominin evolution. And this is when we saw a lot of the Australopithecines, and Australopithecus afarensis comes up during that time. And then there was another wave of climate change, of rapid change back and forth. And a lot of the early hominins died out around this time, but it looks like Australopithecus afarensis evolved into Homo habilis, which was a species we were focused on last week. Habilis appeared around 2.5 million years ago and lasted for about 1 million years. And if you remember habilis from last week, the brain size was a bit bigger. They were making stone tools and they were scavengers. That seems to have been a very successful set of adaptations because they did well and survived another round of climate change. And they evolved into Homo erectus. And that is the species we're going to focus on this week. So Homo erectus shows up right around 2 million years ago in East Africa. So I can show you the family tree that we looked at last week, right? Here's a lot of the different hominins. So we started out 2 weeks ago looking at Australopithecus afarensis. That was Lucy. We'd also mentioned Artie before that, but we highlighted Lucy, the afarensis species, because they were successful and evolved into Homo habilis. That was a species last week. And now this week, we are moving on to talk about Homo erectus. And this is one of my favorite hominin species. So there'll be lots of interesting new changes here. But before I get into the new things about Homo erectus, I want to remind you of what I believe I mentioned at the very end of lecture last week was the name debate about this species, because this is paleoanthropology and there's always name debates about everything. So this week, the name debate is between Homo ergaster and Homo erectus. As we will see this week, this species is going to be quite diverse. We're going to see them in multiple different locations over a long period of time. So there's a lot of variation in the fossils here. So this means there's a debate about the names. Some researchers who are very picky and are focused on differences want to split these fossils up into different names, right? And when they do that, they call the older African fossils Homo ergaster, and then the later, younger Asian fossils Homo erectus. But the other side of this debate is focused more on the similarities in the fossils. And they say, really, they're not that different from each other. They don't look different enough to get their own name. So those researchers lump them all together as Homo erectus. So that's just what I want to mention again, because this week, depending on which reading you're looking at, sometimes they use the name Homo ergaster and sometimes the name Homo erectus. But for the purposes of this class, it's an intro level class. I'm going with the lumper side of the debate, and we're just calling everything Homo erectus. So I just don't want you to get confused in the readings. Ergaster is just the slightly older African fossils, but we're calling them all Homo erectus. Okay, So let's get into talking about this species. So like I said, Homo erectus fossils start showing up around 2 million years ago, and they're in East Africa, where we have been for the past few weeks. You know, Homo habilis was in East Africa, Australopithecus afarensis, Ardipithecus ramidus. East Africa is still where all the action is. So this is the part of the world where we are. So we start finding fossils of Homo erectus here in the Rift Valley of East Africa. So we're going to talk about the fossils, but another thing that shows up with this new species are new tools, okay, stone tools. Last week, we started talking about stone tools, right? And those early stone tools are called Oldowan tools because they're from Olduvai Gorge. You probably remember these from last week, the scavenger hunt article, these sort of simple little stone tools. Well, with this new species, Homo erectus, we start finding new tools. And these are called Acheulean tools. Okay? And they look a bit different than the Oldowan tools. They're made in a different way, and they have a different style, right? As you can see, they tend to have this pattern of being teardrop shaped, right? With a wide end and a narrow end. And instead of the Oldowan tools that are just hit a few times to make a sharp edge or so, these are worked all the way around on both sides of the tool. So they're more sophisticated and more complex to make. Okay. So there's a few different types of Acheulean tools, but like I said, they all fit this sort of standard pattern and standard shape. And this is a picture of what we call an Acheulean hand axe. This is what most of these Acheulean tools are hand axes. So I wanted to give you an idea of the size and shape of these, right? And this is what I was pointing out. To make these tools, they are flaked, struck on all sides, right? They're worked around all sides on the front and the back face of the tool. They're relatively narrow, right? And they have this teardrop shape, and they fit in the palm of your hand. Okay? So sometimes these are described as what you'd say like Swiss Army knife style tools, in that there are multiple tools built into this one hand axe, okay? The two sides are sharpened for cutting, right? The narrow pointed end is perhaps more a puncturing tool. And then you can flip it around and turn it around and hold the narrow end in your hand, and this larger blunt end is for smashing or chopping at things, right? So that's what I mean by multiple tools all in one. So at 2 million years ago on planet Earth, this was the greatest piece of technology on the planet, was this Acheulean hand axe. You know, up to this point, it was the most sophisticated tool ever created. Okay? And it always strikes me sort of how similar it is in size and shape to the tool that a lot of us carry around with us now. But they do slightly different things. There's not a lot of chopping and smashing I can do with this. But this is Acheulean hand axe. So I want you to keep this tool in mind as we're talking about Homo erectus this week in this lecture and the readings. Okay. So let's talk about this new species, Homo erectus, or if you're being picky, some of them are called ergaster. Like I said before, they evolved around 2 million years ago. And this is a very successful species. They last for quite a long time. They stick around till around maybe 100,000 years ago. And they evolved from Homo habilis in East Africa. So I'm going to highlight some things here that are new about this species. The first is the brain. Okay? What we get here is another jump in brain size. We get more encephalization. Okay? So the brain size for Homo erectus increases to around 900 cubic centimeters. And I say around because, like I said earlier, there's a lot of fossils for this species over a long time period. So there's some brains that are smaller, some brains that are larger, but that's the average brain size is around 900 cubic centimeters. And just to remind you, last week, Homo habilis had been the first species where we saw brain size increase, and they were around 630 cubic centimeters. And prior to that, all of the Australopithecines and the other early hominins like Ardi, they had roughly a chimpanzee-sized brain around 400, 450 cubic centimeters. So we're seeing another increase in brain size. What's good about big brains? You guys can think of some benefits of big brains. Basically, it's smarter, right? Larger brains generally mean more intelligence. Okay, so hooray for big brains and being smart. But what's the downside of big brains? Do you guys remember the costs of big brains? The main cost is that larger brains are expensive. You have to feed them. They take a lot of energy to run, okay? So this larger brain is a more expensive brain. So that's worth keeping in mind also when we're thinking about Homo erectus. This week is feeding that big giant brain. All right, another change we see is a change in the teeth, okay? And basically the teeth get smaller here and the enamel gets thinner. We saw this trend start last week with Homo habilis. If you remember, habilis's teeth were a little bit smaller than like Australopithecines, like Lucy's teeth. Now with Homo erectus, teeth are getting even smaller and the enamel is getting thinner. Basically, these are very modern looking teeth. Homo erectus's teeth and your teeth are very, very similar. Small and weak compared to the large, heavy-duty, strong teeth that we saw in earlier species. And then there are some quite surprising, significant changes with the body of this species. Previous species like habilis, afarensis, Lucy, Ardipithecus, Ardi, those hominins were all chimpanzee-sized, right? The same size as chimpanzees and bonobos are today, around 4 feet tall and 100 pounds, okay? Homo erectus gets much taller. We're getting individuals now anywhere from the range of 5 feet to 6 feet tall. Okay? So averaging somewhere around 5.5 feet tall. Okay? This is much bigger than earlier species. Okay? And we get some of the height coming in, basically their legs got longer than we saw with habilis and Australopithecines. And another slight change in the body has to do with the middle section of the body, the torso, okay, the abdomen. They get a more narrow torso and abdomen and a narrow waist. Okay? If you were to look at the rib cage of Homo erectus here in the picture, and you can really see this with modern Homo sapiens, is our lower ribs sort of come in slightly, right? So our rib cage gets narrow at the bottom. This is different from earlier species like habilis and Lucy and all the Australopithecines. They were a little more barrel-chested. They were wider. Their ribs flared out. So Homo erectus's ribs come in and it gets a waist where there's more of a gap here between the hips and the ribs, and it's a more narrow area. So we get a shrinking up here. So basically what we're looking at is a skeleton and a body that is very similar to yours. This looks like a modern human skeleton, with the exception of the brain size. Okay? So Homo erectus brain size is around 900 cubic centimeters. but a modern human brain size for us is around 1,400 cubic centimeters. So we're not at fully modern brain size yet, but from the eyes down, the rest of this skeleton looks very, very modern and very similar to humans today in all of the sizes and proportions of everything going on here. And this is a picture of one of the most famous Homo erectus skeletons, Narukatomi boy, or sometimes called Turkana boy. And it is, if you lay it out next to a Homo sapien skeleton, it looks very similar. Okay. So these are some fairly significant changes going on here. So when we see changes in the hominins, scientists want to know, how did this happen and why did this happen? What explains why these changes are happening in this species at this time? Okay, so now you've got the setup for let's look at Homo erectus and see what's going on here with these changes. And that is my setup for the articles this week, okay? So the two articles, The Naked Truth About Hair Loss and The Cooking Up Bigger Brains. So as usual, when we get to this part of my lecture, I want you to pause my lecture and go look at the student presentation about the articles, participate in the discussion, and then come back here and I'll pick up where the presentation left off and do a little bit about the articles and then move on to some other topics for today. So there you go. See you in a few minutes. Bye. Okay, welcome back. I hope you enjoyed the student presentation. So now I'll sort of pick up where they left off and highlight a few points that I want to make sure you get out of the articles too. All right, so I'll start off with the cooking article. So cooking up bigger brains. So what they're talking about in this article is first the issue of raw food, okay? So raw food, uncooked food. That is what all animals on planet Earth eat and have eaten since the beginning of time, right? That's what animals eat, just raw food. But what is interesting is the research shows that when you look at humans, modern Homo sapiens, it doesn't look like our bodies are built to be able to handle only raw food, okay? And the problem is it is too difficult to get enough energy from raw food for humans, okay? Because as they explained in the article, raw food is harder to break down, right? So your body has to spend more energy digesting and breaking down the food. So you get less energy back from raw food. And we have a big, large body and a large brain, and we need a lot of energy, and a diet of 100% raw food doesn't give us the energy we need. And the other factor that they talk about is the amount of chewing involved in raw food. It is a lot of chewing. And the estimates from the article would be that you would need about 12 pounds of food every day, and you'd have to chew for 6 hours to process that food. So that's also some of the energy that's going into it, is how many hours you spent chewing and then digesting that food, and you're just not getting enough out of it. So an example would be, if any of you, I don't know if any of you have ever tried a raw food diet where you only eat raw foods. It works as a diet because you burn a lot of energy, right, in trying to digest all that food. And it will work as a diet in that you will lose weight, right? And the longer you're on that diet, the more weight you'll lose, and the more weight you'll lose, and the more weight you'll lose until you die. Right? Because our bodies just are not designed to handle 100% only raw food. Okay, so this creates an interesting question, right? For researchers, is the human body, the Homo sapien body, doesn't seem to be designed to run on raw food. And cross-culturally, there are no known groups of people that only eat raw food. All known humans cook their food. So we know, okay, humans cook their food. I wonder when they started cooking their food, right? This came in at some point in our evolutionary history. So they take a look at the fossil ancestors, right? And their attention comes to Homo erectus, okay? And Homo erectus is an interesting species, right? Like I just said in my setup slides, right? What's different about Homo erectus is that they get bigger bodies, right? They got much taller than earlier species. They went from 4 feet tall to like 5.5, 6 feet tall. And the brains got bigger than Homo habilis before them. So large bodies and large brains take more energy, okay? So this species needs more food. But at the same time as you see bodies and brains getting bigger, what shrinks on Homo erectus? The teeth get smaller and the gut, the waist, the torso gets smaller, right? So if you shrink up your waist and your abdomen here, that's where your intestines are. That means you're shrinking up your digestive system. So that's an odd mix of features, right? This is suggesting they're eating less or doing less food processing, and their teeth are smaller and more delicate, right? This doesn't look like they're eating more food to sustain those big bodies and big brains. So what's going on? How can you get a bigger body and a bigger brain at the same time you get smaller gut and smaller teeth? What's the explanation? Wrangham's explanation is, how do you do this? Cooking, okay? Wrangham is suggesting that Homo erectus had to be cooking their food, right? Why? What's good about cooked food? Okay. Cooked food is easier to digest. Okay. It requires much less chewing. Okay. And what fire and heat does is it starts to break down the food before you eat it, right? Think about eating a potato, right? Have any of you ever tried to eat a raw potato? Give it a try sometime, right? Sitting there working your way through eating a raw potato versus a baked potato, right? A soft, fluffy, delicious baked potato, right? Cooked food is easier to digest and you get more energy from cooked food because your body doesn't have to work as hard to process it, right? The heat has already started to break it down, so you get more energy back. And yes, it's true that heat can destroy some of the nutrients in some foods. That's true. It may change the nutritional value of the food, but overall, it will give you more energy than raw food. Okay. So that's the suggestion here, is that, cooking your food, that would explain how Homo erectus could increase its brain and body, both needing more energy, at the same time as it's shrinking up its ability to process large amounts of food, right? Shrinking the gut and shrinking the teeth. Oh, if the food is cooked, if it's soft and already pre-broken down by the heat, you don't need much of a gut system to process that. And small, weak teeth are fine for chewing, soft cooked food versus tough, hard foods. Okay? So this is what he's saying. This is the missing ingredient that explains what's going on with Homo erectus. Okay. Does that make sense? Cooking would explain big bodies, big brains, small guts, small teeth. Okay. But the article also mentions that not all anthropologists agree with this idea, right? It's still, it's a relatively new idea, and it's still a little controversial in that there's not a scientific consensus about this yet. Because what is the main objection to this idea that Homo erectus is cooking their food? The main objection is there's not much evidence of fire in the fossil record at 2 million years ago. Okay. Very limited evidence of controlled fire at this stage, right? A controlled fire would be sort of like a hearth, right? A cooking fire that's used in a setting repeatedly. And that's where you would find burnt, bits of charcoal and burnt wood and ash and bones all together. So that's a fair point, right? It's like, well, we don't see evidence of fire. We don't see evidence of fire until later in the fossil record. So let's hold off on assuming there's cooking going on until we see evidence of fire. That's one of the main objections. Okay, but Wrangham's counter to that counter argument is, he said, basically, he has a sort of twofold response to this, right? He's like, don't worry about the limited evidence for two reasons. Number one is, he says there would not be evidence of fire at this stage. And the fact that we don't find evidence of fire makes sense. And that would be talking about Homo erectus's lifestyle, right? This is a nomadic species, right? They are wandering around, moving around on, the plains of Africa. So imagine Homo erectus out there, they, get some meat that they want to cook. They create a little campfire and cook it up and eat it. And then they move on. What's left over from cooking their lunch? Little bits of burnt wood and ash. What happens to that burnt wood and ash? How long is that going to stay there? All you need is a strong wind. It blows it all away. One rain will wash it away. He's saying because this species is nomadic and moving around, the fire evidence is not going to accumulate and not going to stick around for long enough for you to be able to find it 2 million years ago. So he said there's no way you'd find evidence of little campfires 2 million years ago. So that's one way he says it. And number two is, he said, do you want evidence of fire 2 million years ago? Look at the bodies. That's your evidence. Homo erectus's body. Larger brains and larger bodies with a small gut and small teeth. That's the evidence that they were cooking. If they were not cooking, then you need some other explanation for how they got their bodies so big and their brains so big. So he's arguing his idea of fire and cooking is the best explanation for what's going on there. All right. So that's the cooking article, basically. It's a relatively straightforward little article there. Okay. So you can agree with Wrangham, agree with this cooking idea or not. That's perfectly fine. It's, like I said, it's an open debate in anthropology right now. So let's say if you're, writing an exam answer about Homo erectus this week and are talking about whether or not they cooked with fire, that's what you can talk about, right? You can think they did, you can think they didn't, just explain if you think there's enough one way or the other. If you think it looks like they were cooking, or you think, no, not yet. Okay. And the only other thing I wanted to mention at this stage that might be worth thinking about is, how, if they're cooking with fire at this stage, how did they figure that out? How did they discover that in the first place? Right. So depending on the questions for the article discussion this week, we can talk about it over in the article discussion, or we can talk about it in the lecture discussion. But that's something I'd like to talk about, is I want to see some of your guys' ideas about how they begin, how this starts, cooking with fire. Okay. So the other article for this week was The Naked Truth. Okay. So this is looking at another strange thing about humans, right? The first strange thing was that we cook our food. The second strange thing is that we seem to be oddly naked, because most mammals are covered in hair, right? That's kind of a defining feature of mammals. So the article talked about, right, some of the benefits of being covered in fur. That was in the articles in the presentation, right? You know, fur has various protective qualities. It can protect you from, you know, cold and sun and abrasions. But there are a few mammals out there that don't have fur. So it talked about what benefit those mammals get from not having fur. And that could be things like some of the aquatic mammals, that it's more hydrodynamic to lose your fur for swimming, or some of the really large mammals like elephants and rhinos and hippos that lost their fur to stay cool in really hot climates. And then there's those naked mole rats that are just living their naked, happy lives underground and doing their own thing. Okay. So we know Homo sapiens as a species don't have fur. So we're trying to figure out when, right? When did this change happen, right? When in the history of our ancestors did they lose their fur? So the article, Jablonski, she's making some comparisons and looking at human skin and human hair and chimpanzee skin and chimpanzee hair. And she said, interestingly, our skin is more waterproof and is actually a little tougher and more cut resistant than chimpanzees, you know. And that makes sense because chimpanzees are covered in fur, right? So the fur, you know, blocks most of the small cuts and scrapes, right? So our skin that's furless has to be a little stronger than chimpanzee skin. We do have hair, but the hair that we have is weaker and more breakable than chimpanzee hair and fur, right? And again, that makes sense. Theirs is used for protection. Ours doesn't seem to be, so it's sort of maybe just less sturdy and maybe a little more decorative. And the other big section of the article was about sweat. A lot of different mammals sweat, but they don't all sweat the same. Okay. So typical mammals sweat. They sweat through the pores in their skin. And usually mammals have a lot of apocrine glands, right? And produce very oily sweat. So when they sweat, their fur gets really coated in oil. And what she points out is that is not good for cooling, to have a fur coat that suddenly becomes all clumped and matted and oily, okay? So it doesn't work as a cooling mechanism. How do most mammals cool off is they pant, right? You've probably seen this in a dog when it gets hot, you know, they pant. They do the evaporative cooling through their tongue, okay? And that's their cooling mechanism. If they can't pant, then they can overheat. Okay. If you look at human sweat, we have more eccrine glands. So we do have some of the oil glands, but we produce a lot more water in our sweat. So we have a very watery sweat. And what that does is that evaporates much more easily than the oily sweat of most mammals. So when your sweat, the liquid evaporates from the surface of your skin, it pulls the heat off of your body and it helps cool you down. So that's straight from the article. Oh, there is one little interesting thing that kind of gets touched on in the article, but not fully. Is there some interesting research on lice and the evolution of lice and some of the DNA evidence? And what they've looked at is that humans have 2 species of lice that parasitize us, right? We can get lice in the hair on our head, and we can get lice in the hair in our genital regions, pubic lice. And they're 2 different species. And when you sequence their DNA, you can look at sort of when they evolved and when they split from each other. And it looks like the species of lice, pubic lice for humans, evolved around 2 million years ago. And for a while, that was the only species of lice we had in our body, was the lice in the pubic region. And we didn't have any lice anywhere else. And it looks like the species of lice that we have now, the head lice, that's a younger species that evolved around 500,000 years ago. Okay. So I just wanted to mention this because it fits in here, is that for a while, we probably only had pubic lice because that may have been the only place we had hair on our body. And the rest, the hairless parts of our body were lice-free, right? Except for the hair on our head, right? We had hair on our head, but apparently there's this hairless area that lice couldn't cross without getting grabbed and picked off, right? And it wasn't until much later, maybe around 500,000 years ago, this will come up in a few weeks in this class, maybe when we started wearing clothes, that the lice were able to migrate and move and colonize and adapt to our head. And we got a speciation event in lice up there much, much later in our existence. But there may have been a barren area on our body for a long period of time. Okay. So going on from lice, I just wanted to add that in. Okay, so if again, we're trying to figure out when and why hominins lost their body hair. Okay, so last week we talked about Homo habilis. They were bipedal, they were scavenging, and every indication they were still covered in fur, right? Because our ancestors were, had bodies like chimps and bonobos, typical ape covered in fur. All the early hominins would have been covered in fur. Artie and Lucy and habilis, everybody's got fur. But then this week we meet Homo erectus, okay? And Homo erectus is a little bit different, okay? The article mentions that they had different body proportions, okay? We know this, right? Taller, big brains, all that fun stuff. And the article mentions they had higher activity levels, okay? So this is what we can think about now, right? It appears they were doing activities or more activities that earlier species were not doing. Okay. So what's the activity that Homo erectus is doing that all the earlier hominins were doing before? Okay. And it's not just walking, right? Because all the other hominins had been walking around on the African savanna for 4 million years, okay? What it looks like, the new activity here that is different from earlier hominins is running, okay? Homo erectus appears to have a body designed to run, okay? And it's not really a fast body. Remember, we talked about this like 2 or 3 weeks ago when we talked about hominins and being bipedal and how many animals you can outrun. Aside from turtles, there's not much you can outrun, right? So this is not a fast body, but it does look like Homo erectus has a body designed for running long distances. Okay. Long legs, a good runner's body. Okay. So they're doing this new activity, this higher activity levels of running around on the savanna. So imagine running around at the equator, in Africa, on a hot day, right? That's a dangerous activity, okay? You're going to overheat. So how did Homo erectus prevent from overheating, performing these higher activity levels on the African savanna? Why weren't they overheating? Because this is when they lost their fur, right? Do you want to go running around on a hot day here in San Diego in a fur coat? No, right? So they got rid of their fur, right? Lost their fur coat, and the sweat glands changed, right? From oily sweat to watery sweat, okay? And that allowed them to cool off. So now they can run around for long distances without overheating because they lost their fur and they got nice watery sweat. Okay, so that makes sense. Naked jogging, good times. Okay, but what's the problem of running around naked at the equator, in the hot sun? Right? The problem is you expose your skin to lots of UV radiation, right? And I assume you guys have heard the problems with UV radiation and how dangerous that can be, right? So that's what I want you to think about now. If Homo erectus lost their fur and were running around naked, how did they protect their skin? So, the issues here are some of the ways that students usually think about protecting your skin could be like hiding in the shade, right? Or wearing clothes. But do you want to go running in the heat with a lot of clothes on? Maybe not. Staying in the shade prevents you from going out looking for food, right? So you don't want to be sedentary. You got a lot of food to get. You don't want to cover yourself in clothes. And what would clothes be at this stage? Like animal skins, right? That's just putting a fur coat back on to go for a jog. That's crazy. Sometimes people suggest maybe covering themselves in mud. That would protect you from the sun, but that would clog your pores and prevent you from sweating, so you'd overheat that way. So how do they protect their skin from the sun and from those dangerous UV rays? Right? These days, we just go down, to CVS and buy some sunscreen, or I suppose order it online these days. But they didn't have the ability to go find sunscreen. So what they got was nature's sunscreen. That's melanin, okay? Melanin is the pigment in your skin cells that makes your skin darker, okay? Melanin protects your skin from UV rays, right? The more melanin you have, the more UV rays are reflected off of your skin, and that's your protection from UV radiation. And it looks like from some other DNA and genetic research, it looks like around, 1.5 million years ago, we see a rapid increase in the genes for dark skin pigmentation and an increase in melanin production, right? And what you want to think about here is how long it takes somebody with dark skin to get a sunburn versus how long it takes somebody with really pale skin to get a sunburn, right? Pale skin will burn very quickly. Dark skin takes much longer to be damaged by the sun. Right? That's what's going on here. So as their fur decreased, right, as they got less and less fur, they would have had to increase their melanin to protect it, right, to protect their skin as the protection from the fur went away. So this is when our ancestors got naked and dark-skinned at the same time. Okay. But the article, and this idea also, the article talks about, right, we lost most of our fur, at this stage, but we still do have hair on our bodies in a few different places. Okay? And that is also worth thinking about, is why do we still have hair in some places? Why are we not completely naked, right? With the exception of strange cultural practices of like manscaping and, laser waxing and all sorts of crazy stuff. We still normally have some body hair, right? So the article mentions a few functions of the hair that we have left. It can provide shade. That's like talking about the hair on your head, right? Running around at the equator in the sun is baking down on your head. If your head overheats, you'll go into heat stroke and shock and die, right? So hair can provide some shade up here to protect your head. Lubrication, that was the idea of we have hair in some high friction areas. Think about running or jogging, right? You're moving a lot, you got a lot of friction around your armpits and your inner thighs and your groin area. So the hair that you have there may be to accumulate water and some of the oil that is still in our sweat to prevent chafing, when you're running. So that's the lubrication idea. It can also be a scent trap, right? Hair can trap smell. And it's worth thinking about here, right? Worth pointing out that smell and pheromones can play a role in mate attraction and bonding, right? And this idea seems weird to Americans, well, at least people living in the United States, because people who live in the United States are strange. They have really weird ideas about things, and they have really strong issues with body odor, okay? Why is that? Why are Americans so averse to body odor? And what I want you to think about is think about all the animals on the planet, right? How many of them, how to say this, right? How many animals on the planet think other members of their species smell bad and smell gross, right? Think about what you think about human body odor, right? You think other people stink, right? How many animals on the planet, do squirrels think that other squirrels stink? What other animal thinks other animals smell bad, right? I mean, think about dogs. The whole thing they do when they meet each other is they smell each other, right? It's weird. Why do we think humans stink? Any guesses as to why that is? It's basically capitalism. Think about how many products out there are designed to make you smell better, right? If you think you smell bad, that means you got to go buy something to change your smell, okay? There is no end to the number of products that have scents and perfumes, to make you smell anything other than human, right? Because you are trained and taught to think that humans smell bad, okay? So that you'll go buy stuff, so that you'll be insecure about it and go buy things. So cross-culturally, that's a weird thing that Americans have, is issues with body odor. If you travel around to other parts of the world and other cultures, you'll see there's a lot of variation in that. Okay. And the other thing to point out here may be the idea about how smell and pheromones can relate to sexual attraction and bonding in relationships. There's quite a lot of studies that show that humans do respond to the smells of other people, and that can be a big component of attraction, right? So if you're in a relationship with somebody or have been in a relationship with somebody, have you experienced that, of being in a relationship with somebody who smells really good? I'm not talking about the perfume that they buy, but them, how they smell, right? If you like the way somebody smells, that's a big part of attraction, right? If you've never dated somebody who you really liked how they smelled, maybe you're young and you'll have some more interesting life experiences as you get older, but hopefully you'll experience that at some part of your life. And then it'll make sense, the psychology studies and the research they show about how people respond to the smells of other people. So keep that in mind when you're, I guess that's something hard to figure out when you're doing online dating and things like that, of how people smell, but that might be worth remembering. Okay. So that may be some of the functions of the hair that we still have. Okay. Now I want to mention, going back to this higher activity levels and Homo erectus is running. Why was Homo erectus running? What was the point of that? Had they been locked in a coronavirus quarantine for months and were getting fat and decided, I got to go run? Probably not, right? Why was Homo erectus running? What explains those higher activity levels? Were they just going out for a jog? No, this was an adaptation to a new activity that Homo erectus was doing. And this is called persistence hunting, okay? It is the strategy of chasing down prey. Okay. So what we see at this stage, right, is around this time period with Homo erectus, we start to see evidence of hunting on the bones. Remember last week when the scavenger hunt article, Pat Shipman, she was looking at the Olduvai Gorge bones and was not finding evidence of hunting. She was finding evidence of scavenging. That shifts over the next million years. We start seeing patterns of disarticulation and going after big hunks of meat, and the cuts from the bone tools are made first before the scavengers get there. So now we start to see evidence on the prey, of the bones of the prey at this time period. Okay, so how this worked is, again, Homo erectus is not fast. Bipeds are not fast. So what you want to think about is when they were running. This would be, again, we're talking about East Africa on the equator in the savannas, is the middle of the day when it is really hot. And what are most animals doing at the hottest point of the day? They're taking a nap and relaxing in the shade, okay? Because it's too damn hot to do anything. Okay? So imagine a zebra sort of chilling under a tree in the shade, in the middle of the day. Everybody's sleeping then. And they're not too worried because the predators are sleeping then too, right? Cats, they love to sleep in the middle of the day. They mostly do all their hunting and activity in the morning or evening or night. So you got a zebra chilling under a tree in the middle of the day. And it looks over, and what does it see? A Homo erectus come running towards it, right? Waving their, sharp rock, their Acheulean hand axe. They got their Acheulean hand axe in their hand, right? One thing to think about is, Homo erectus, if it's going to hunt, how's it going to kill something with that hand axe? Get up close and throw it at it and hit it between the eyes? Would be a really lucky shot. And what if you just hit it on the shoulder? Then you're going to piss it off, right? So they don't have throwing weapons. They just have the sharp rock that they're running at you with. Okay, so what does the zebra do? Runs, Is it faster than Homo erectus? Hell yeah, everything's faster than Homo erectus, right? So it sprints off, and runs away, and then stops, and it's like, fucking stupid apes, right? And then, it starts panting and looking around. It's like, it's fucking hot today. I need to go find a place to rest, right? And as it's looking for shade, it looks back, and what does it see? Homo erectus still coming at it, right? So the zebra runs again, and runs away, sprints away super fast, right? And then stops, and it's like, fuck, it's hot today. I did not plan on running. This sucks, right? Maybe it's, its fur is starting to get oily and matted, and it's like, oh, this is getting painful. And it looks back, Homo erectus, still coming, right? It's like those old horror movies of the monster that just keeps coming, just keeps coming, just keeps coming. And you're running and running and can't get away, right? So the animal like the zebra, or the antelope just keeps running and keeps running and keeps sprinting away, getting hotter and hotter and hotter. Homo erectus is jogging along, sweating, cooling off as it's going, and then what happens when the animal gets too hot, right? You go into heat stroke or heat exhaustion, right? Has anybody experienced that? You get all shaky and nauseous, right? You can pass out, right? And then as you're laying there on the ground twitching, Homo erectus just comes up and takes you out with that hand axe, right? So that's the hunting style, is this persistence hunting. Is you're not fast, but Homo erectus can run for long distances with their hairless body and their long legs and their dark skin to protect them from the sun, and they just run animals into exhaustion. And this is a style of hunting that's still done by some nomadic foraging peoples today, like the Kung San down in southern Africa. You can look up videos of the Kung, a bunch of guys getting together and running down large antelope, just running them into exhaustion and then going up and finishing them off. So that's what's going on here with Homo erectus. And then we can ask, right, so why? why are they going through all that trouble, to now start hunting? Right? What's different? None of the earlier hominins were hunters. Why does Homo erectus have to start hunting? What's changing? Right? Climate change and bigger brains are here, right? Climate change we read about last week. Remember, climate is rapidly shifting. The food supplies that we're used to, are changing or going away. So they need to find new foods, right? We talked about scavenging. That can get you some, better quality food and some energy. But, if you want to get bigger and get a bigger brain that needs more energy, you need more food to feed it. So you need more of that, meat and fat in your diet. So climate change was probably the trigger again, and the adaptation of getting bigger brains to figure out how to make better tools and to hunt and take down animals. That's the package that's going on here. Okay. Hopefully that all makes sense. So what I want to do now, that's sort of how the article, I'm going to put this together in a timeline to explain the loss of body hair that we see with hominins. Okay, and you know all of this already, I think, so I'm just putting it together in a timeline sort of way, in a chronological order. Okay, so if we jump back a couple of weeks ago in this class, right, to about 10 to 8 million years ago, back when Africa was still relatively wet, our ancestors at that point were forest apes, right? Quadrupedal forest apes, swinging in the trees, climbing around. What they were is they looked like chimpanzees and bonobos today. They had dark fur. And if you remember, I think a couple of weeks ago, I showed you some pictures of chimpanzees without fur. They have relatively light skin, right? Chimps and bonobos, even gorillas have relatively light skin under their dark fur, right? Sometimes you'll see their faces darken up, but under the fur, it's light. That's what we see in the modern apes, like chimps and bonobos and gorillas. So that's our starting point. A forest ape covered in fur with light skin under it. So what happens then is 2 weeks ago, around 8 million years ago, Africa starts to dry out, right? That's that big, long drying trend. The rainforests are shrinking. The savanna grasslands are opening up. That's when we start seeing the early hominins around 6 million years ago, multiple species. And this is when we get species like Artie, and then all the Australopithecines, including Lucy. They're now bipedal and walking around in the savanna, but they're still covered in fur. Then last week, we got another round of climate change around 3 to 2.5 million years ago. That rapid change back and forth between wet and dry. This is when some of the earlier hominins died out and Homo habilis appears and they start making Oldowan tools, right? And life is hard for them. They're running out of food to eat, so they start trying new things. As they're walking around out in the savannah foraging for their plant foods, they start scavenging too and scraping off bits of meat and breaking the bones with their little tools, getting some bone marrow, maybe eating some brains. They would have still been covered in fur at this stage for all the benefits of being covered in fur. And remember, they're just walking around. Then, around 2 million years ago, another round of climate change starts up, right? Things had been stable for a little while, for about 500 million years, but then rapid climate change again. This wipes out some of the other hominins. And this is where we see Homo erectus evolves 2 million years ago with new body features, right? And what we see with them is, like I said before, they get much longer legs than we see before. Long legs are great for covering large distances. They get more muscular in certain parts of the body, particularly the lower part of the body. Think about the muscles that you need to run, right? What muscles are important for running? Okay. There's your leg muscles, right? And then what is the largest muscle on your body? Do you guys know what that muscle is? It is the gluteus maximus, your butt, right? That's the biggest muscle in your body. That's a muscle for pulling your leg back, right? While you're running, okay? So Homo erectus also got muscular butts at this stage. So if you're a fan of butts, you can thank Homo erectus for that 2 million years ago. The waist gets narrow, you know, and that's part of the pivoting that the body does when it's running. Everything here is designed for running and persistence hunting. Oh, I didn't mention this. There's also this thing called a nuchal tendon. Okay. What I want you to do now is feel the back of your head, okay? If you feel the lower back of your head, sort of for me, it's where my braid comes in, sort of the top of your neck, the base of your skull. Do any of you have a little bump back there on your skull? For me, if I feel the top of my neck, right, where my skull is, I can feel like it feels like a little marble there. Anybody else have that? I wish it was in class and I could see if you guys do. If you have a weird little bump there, have any of you ever wondered or are wondering now, what the fuck is that? What that is, that's a bit of your skull. It's a little protrusion in your skull. That's an attachment for a special tendon that runs down the back of your neck between your shoulders, right? And this tendon is a unique feature in humans. But if you don't have it, that's fine. There's variation there, and sometimes you can't feel the bump. You probably have the tendon, even if you can't feel the bump. But that tendon is designed to stabilize your head while you're running so that you're not a bobblehead doll with your head bouncing around. So if you have that little bump in the back of your skull, guess where in the fossil record the first time that little bump appears? Homo erectus, 2 million years ago, has that little bump on the back of their skull for that tendon attachment. So their bodies are designed for running and persistence hunting, right? The other part of that is they lost their fur, right? And that's for watery sweat to prevent overheating. And as I mentioned, the skin gets darker, right? Because you need melanin to protect from the UV rays and protect from the sun. So hooray for melanin. Everybody got very dark skin at this stage. And then I mentioned they lost their fur, but they kept some of it. I mentioned the fur on the head, right? And the article mentioned that could provide shade, okay? But I want you to think about something else here, is that not all hair is the same, okay? So think about my hair, right? Imagine if for some insane reason I went out running on a hot day, right? Do you think this hair keeps my head cool and fresh? No, it does not, right? This hair, it's like wrapping a potato in aluminum foil, right? It bakes my head and would cause me to overheat, okay? So this is not the hair you want to run around on the equator in a hot day. What kind of hair do you need? The kind of hair you need is tightly curled, kinky, afro-style hair. Why? Because that hair does what mine fails to do, right? My hair traps heat, okay? Tightly curled hair gives you both shade and airflow to let the water evaporate off and keeps your head from cooling, keeps your head cool and keeps your head from overheating. So that's the kind of hair that would have been on our heads at this stage, is the tightly curled hair, right? Because that's the adaptation that's beneficial. This, at 2 million years ago, would be a fatal mutation, right? That would kill you. So nobody had straight hair like this at this stage because it'd be too dangerous. That probably came much later in like different settings and different climates. At this stage, tightly curled hair, that's what you need to stay cool. Okay, so this is what we have. Homo erectus with these sets of adaptations, changes in their body, the body proportions, the lost hair, dark skin, tightly curled hair, and it's all for running and hunting to survive 2 million years ago. Make sense? Again, if there's any questions about anything, we can talk about it in the discussion. You know. So when you see reconstructions and drawings of what Homo erectus looked like, a lot of times you'll see things like this, right? Is possibilities for Homo erectus. I think the hair up here in the right and bottom left are pretty accurate for what we'd probably have at this stage. Dark skin for sure. This guy in the bottom right, that's got straighter hair. That might have come later when Homo erectus moved to some other areas. We'll talk about that in a few minutes. But the idea with Homo erectus is the biggest difference is you can see this guy up here is sort of the slope back forehead. They don't have much of a forehead because their brains are not as large as ours yet. Right? It's only a 900 cubic centimeter brain. But if you put a hat on Homo erectus, the idea is Homo erectus looks pretty much like us. And from a distance, if you saw a Homo erectus with a hat on, you might say, what's that big naked guy walking around for? But basically the idea is, from the eyes down, it's pretty much the same as modern humans are today. Okay, so what's my next slide? I think this is just a review of Homo erectus, what we have so far. Big brains, better tools, big bodies, long limbs, running abilities, hunting, hairless, sweaty, dark skin, smaller guts, smaller teeth, fire, maybe cooking. Okay, one thing I can add in here is that, I don't know if this will be helpful to you or not, but I can give it a try. These species names, right? We're starting to deal with a whole bunch of species names in the second half of the semester in this part of the course with the fossils. And these Latin names are hard to spell, hard to pronounce, kind of hard to keep track of, right? Personally, I think Homo erectus is the easiest name to keep track of out of all of these, okay? So I'll give you my memory device for this one, okay? So how it goes is think about the name Homo erectus. Think about teaching that name to middle school kids, right? If you went to a middle school, a bunch of sixth graders and said, I'm going to teach you about Homo erectus, how would they react to that name? Okay. The name sounds a little dirty, a little inappropriate, right? Homo erectus, right? Use that if you can, right? Homo erectus, that's kind of a dirty sounding species name. Sounds a little weird, but think about the species, right? What do we know about Homo erectus? They were tall, dark, naked, sweaty, with good butts, Homo erectus was the sexiest of all the hominins, and they have the dirty sounding name. So there you go, and they were smart and they could probably cook you dinner. That's pretty sexy. If that helps you remember Homo erectus, good. If not, you can just block that out from your mind and move on and not think about that anymore. But I thought I'd just offer that up as a way to remember this species. Okay, so let's move on. Now that we have Homo erectus, let's talk about some other interesting things about them. Let's talk about location. Okay, out of Africa. For the past few weeks, we've been focused on Africa, right? Because all the early hominins were found only in Africa. Okay? The very earliest hominins like Ardipithecus and all those at 6 to 4 million years ago were in Africa. Lucy and all the other Australopithecines, they were in Africa. Homo habilis last week, Africa. The early Homo erectus fossils 2 million years ago, Africa. But then around 2 million years ago, little after that, right, we get Homo erectus, and then we start to find Homo erectus fossils outside of Africa after 2 million years ago. So now we're going to move to talk about some other parts of the world, okay? So I showed you this map a little while ago with early Homo erectus sites here in East Africa. Now we start finding them in other places, right? They're moving outside of Africa. So here is a timeline for Homo erectus. What we've got along the top row are how many millions of years ago we're talking about, and in different locations. So, 2 million years ago, 1.8 million years ago, we've got Homo erectus in East Africa, and then we have them all throughout East Africa for the next million years. Then we start finding them a little bit later, around 1 million years ago, up in Europe, and then Java. That's what we know as Southeast Asia, places like Indonesia, around 1 million years ago. And then we start finding them in East Asia, lots of Homo erectus in China, about 800,000 to 500,000, 400,000 years ago. So Homo erectus starts expanding out of Africa. And what we end up with is a map sort of like this, where this sort of, what color is this? Blue, green. This bluish green color is where it looks like Homo erectus was living. So we have them through the Middle East, up into Europe, in India, lots of them in the Far East and China, and then down here in Southeast Asia. I suppose it's worth noting where we do not find Homo erectus yet, or at all. We don't have Homo erectus in Australia. They apparently never made it that far. And we don't have Homo erectus too far north, up into these more Arctic, colder regions. They tended to stay in some of the more warmer areas. And we definitely don't have them in the Americas. They never made it over here. But still, this is a bigger geographic location than we've ever seen before. And for most of these locations, they can just walk out of here. On this map, it'd be more accurate if that was connected, because you can just walk from northeastern Egypt into the Middle East here. Down here on some of these Southeast Asian islands, there's a chance they might have crossed some water to get there, but we're not completely sure, because depending on when they moved, climate change can raise and lower sea levels, as I'm sure you guys have heard about in the news. So at certain periods of time during the climate change that we read about last week, sea levels were low enough where they might have been able to walk. The land would have connected all the way down here, and they may have walked straight down here. But if they came at other times when the sea levels were high, they may have had to cross small amounts of water to get there. So that's, again, worth keeping in mind with Homo erectus. But it looks like they couldn't cross substantial amounts of water. Like they couldn't make it all the way over here into Australia and some of these other islands, and possibly because that's like 40, 50 miles of open ocean, and that was too much for them. But this is where we have them, where we have Homo erectus fossils. The red dots are fossil finds, and the blue-green is sort of where we think they were living. All right. So that's new areas. What else do I want to mention about these guys? I'll go back to the tools that I started this lecture with, right? Like the very earliest Homo erectus fossils are found with Odowan tools, okay? Those ones from Homo habilis. But then they start developing the Acheulean tools that I talked about in the beginning of the lecture, that teardrop-shaped one with a hand axe, right? And I already explained to you guys, these are more sophisticated tools. They're worked all the way around, so they're better at food processing. They're just a more useful tool. So a couple of other things I want to mention about these tools are that there is very little geographic variation in these tools, right? You find the same basic hand axe throughout East Africa, Southern Africa. You find the same hand axe in Northern Africa, in the Middle East, up into Europe, all the way over here in India. So what does that mean? That you find the same hand axe everywhere, right? One of the things that may mean is that they are sharing a cultural tradition in their tools, right? So the idea and the method of making these tools is traveling with Homo erectus, right? And this same idea. So, there can be observational learning. Maybe could there be teaching at this stage? Don't know, but they all seem to be learning how to make the same style of hand axe in different parts of the world. So there seems to be a shared culture throughout all these Homo erectus sites. Interestingly, we don't seem to find these hand axes in East Asia, in the Chinese sites. So perhaps we don't find many stone tools there for Homo erectus. And it's not sure why. One possibility is maybe they're using something else as a tool. East Asia does have bamboo. And if you've ever played around with bamboo, you can use that, put an edge on it and use it for a knife or a spear sometimes. So maybe they switched to something else. Or maybe we just haven't found the hand axes out there. But we do see the same style of hand axe in all the other sites. Okay, another thing to keep in mind, right, is they invented this hand axe at 1.5 million years ago. Okay. And once they invented it, they kept making it for the next 1,000,000 years. They continued making the same hand axe. Okay. Why? Why did they keep making it for 1,000,000 years? Because it was awesome and they didn't need to change. That could be it. I mean, what's one of the interesting things about the hand axe is it's a handheld tool, right? There's no evidence that anybody ever put a handle on it, right? Or fashioned it into so they never made a spear out of it. So it was never a throwing weapon. Did they never think about making a spear in 1,000,000 years? Or maybe they just didn't have, capitalism and marketing again, right? Because I'm thinking about this other tool that's shaped somewhat like a hand axe, right? What are the chances this is going to be still functional in 1,000,000 years? Right? Probably not, right? So nobody was trying to sell them hand axe 2.0. It's like, this is the one you need. It's got all the new features this year, and you're going to be embarrassed if your friends see you using hand axe 1.0. It's hard to say for sure, but I just want you to think about that and keep that in mind when you think about Homo erectus. And, the greatest piece of technology on Earth stayed the same for 1,000,000 years. Okay. So another thing I want to talk about now is let's go back to talk about location. Okay. And this chart, it looks a little ugly at first glance. Okay. But what it is the blue coloration is the population of hominins we're talking about, okay? And this vertical axis here on the left is how many millions of years ago. And then the horizontal axis on top is location, okay? Because now we have to take both time and location into account. So for Homo erectus, remember this chart is just being a little picky and calling the older ones ergaster, but for us, this is erectus too. So erectus starts out in Africa around 2 million years ago and starts, expanding, and then they spread and they branch out over into Asia, right? And they move, right? So what I want to talk about is what's new, this movement and spread, okay? That's different than what we've ever seen before. Everybody else we've seen before was isolated to Africa, right? And especially East Africa. So let's think about that, okay? How is it that Homo erectus was the first species, the first hominin species to be able to spread out of Africa? Why did they do it when nobody else before had been able to? And to think about this, we can think about different changes that we see with Homo erectus, right? One of the things we can think about is their bodies. Right? They were bigger than earlier species. Could that have helped them spread out of Africa? what would be good about having a bigger body that could make it easier to spread and migrate, right? So some ideas here could be, right? It might be easier to travel if you're larger, right? Think about having really long legs, right? And going on a hike with somebody who has really long legs versus really short legs, right? Long legs, you can just travel distance easier. So maybe it was easier for them to walk long distances and move to new areas with their long legs. Another issue is that they were bigger with big bodies. Maybe they needed more food. Okay, so they were motivated to search out new areas to find more food because they had bigger energy demands. Protection is the idea is like being bigger might have offered them more protection and safety from predators, right? They were less likely to get eaten. So maybe that freed them up to be safer to move and travel long distances away from the safety of their homes. Another interesting thing about erectus is they had bigger brains. Okay? So think about that. How could their bigger brains be part of the reason why they spread out of Africa? Right? You know, so some ideas here, right? They were probably more intelligent than earlier species. Could being more intelligent help you spread and migrate into new areas? You know, figure out new ways of living, how to handle new environments, new habitats, new foods, new challenges. Being smarter frees you up to do that. Yeah. Maybe their big brains changed their personality, right? Maybe they got curious and just wanted to see what was out there, you know, and wanted to explore with their big brains. Right? They had different culture, right? With those big brains. Culture and technology kind of go together here, right? New tools, better technology. Maybe they were better at working together as a group. They were probably hunting together as a group. Maybe those advantages helped them spread out of Africa. Did they have language at this stage? You know, I know language has come up a few times already this semester. It's popped up in the discussions, you know, and people have wondered, students have wondered, do they have language yet? What do you think? Did Homo erectus have language capabilities, or what kind of language capabilities did they have? Right? Their brain is 900 cubic centimeters. That's twice as large as a chimpanzee, right? But, you know, little more than half the size of our modern brains at 1400. So I want you to think about that and maybe bring it up in the discussion. Did they have language? Do you think yes? Do you think no? What would be the evidence for it? What would make you think they did, right? How would we prove whether they had language or not? So let's talk about that some more in the discussion board this week. We talked about this week fire, right? Do they have fire? Maybe, possibly, you know. So if maybe they had fire, you know, and they're cooking their food, could that be why they're able to spread, right? Cooked food gives you more energy for traveling and migrating. It can give you warmth. Some of the new areas they're moving into are much less hot than equatorial Africa. So maybe fire allowed them to expand into new environments that were colder. Protection, fire can also give you protection and keep you safe from predators, right? So maybe that's part of what allowed them the freedom to move and expand. So again, it's an open debate whether you think they had fire, had control of fire or not at this stage, but if they did, that could certainly be part of the story as to why they're able to spread. And like I mentioned, what are they eating? This species is eating a lot more meat than earlier hominins are, right? They're hunting, okay? Could meat and hunting be part of the reasons why they spread out, right? That could factor in different ways, right? maybe they're just following their prey, right? They're hunters now, and the wildebeest are migrating, and they're like, hey, lunch is moving, let's follow lunch, right? And they just went where the animals went. Meat is a good quality food, especially if you're cooking it and getting a lot of energy from it, so that can help you travel and move to new areas. And then this idea, right? What's the danger of moving to a new place, a new environment, a new habitat, right? You're surrounded by all different plants, right? It's not all palm trees and eucalyptus. And you're looking around and like, oh, here's a bush I've never seen before with some berries. I guess I'll try them. What's the risk of trying new plant foods? They can be poisonous, right? But what are the chances you're going to run into a poisonous deer? No, right? Meat is generally a safe food, especially when compared to plants, right? Plants have a high risk of being toxic and poisonous, but if you eat meat, that can give you a safe, reliable food source to then let you experiment slowly and carefully with the different plant foods around, right? So maybe eating meat helped them spread around to different areas. All right. So there's all these possibilities with Homo erectus and all the ways that Homo erectus are a bit different, right? With their big bodies, their big brains, different diets, advanced technology and culture. In some respects, it is not surprising that this is the first species we see that expands beyond Africa into the Middle East and Asia and parts of Europe. Does that make sense? Homo erectus, awesome in many ways, lots of new changes. Okay. I hope I have given you enough information, to talk about Homo erectus for your exam answer this week and discuss all sorts of new changes with this species. And if this is clear, good. And if everything makes sense this week, good. Anything you want to ask questions about, go over to the discussion board and we'll talk about it there more. But I hope this week is clear and makes sense, because next week, things are going to get a little bit more confusing. So be ready for that. All right, but I'll leave it there, and I'll see you in the discussions this week. Bye.